Alright guys, welcome to this page of the notes, and let's go ahead and do one more example problem together. Actually, hopefully you're coming back, you've tried this one on your own, and you're just checking to see if you get the same thing that I get, just to make sure that you're doing them correctly. Again, it's just review from chapter 5, multiplying and dividing polynomials. The only difference here is I'm calling them functions in this case. Here in chapter 6, we just call them functions. So, here we go, f of x times g of x. No need to rewrite it. We know what it means. We've done it several times at this point. So you're going to do x squared plus 5x minus 1 multiplied by 3x minus 2. And we use the distributive property to do that. X squared times 3x is going to be 3x cubed. X squared times a negative 2 is going to be minus 2x squared. 5x times 3x is going to be plus 15x. 5x times a negative 2 is going to be a minus 10x. Negative 1 times 3x is going to be minus 3x. Sorry, hold up, I apologize. Hang on. 5x times 3x, 15, but x times x is x squared. There we go. All right, the rest of it is right. So then we have the 5x times the negative 2, which is minus 10x, and then negative 1 times 3x, which is minus 3x, and negative 1 times a negative 2 is going to be a positive 2. Combine like terms if you have any. Cross them off as you use them so we don't overuse them. 3x cubed is the only cubed I've got. Minus 2x squared plus 15x squared should leave me with a positive 13x squared. Negative 10x minus 3x should be minus 13x, and then plus 2. And that is going to be my product function, the product of multiplying f of x times g of x. Okay, I got another one down here, division. Let's go ahead and set it up. Again, we should recognize the terminology at this, or the notation terminology. The notation at this point just means we're going to do f of x divided by g of x, which means you're going to have x squared plus 5x minus 1 divided by 3x minus 2. And again, I've got a situation here where synthetic division isn't going to work out. Yes, this x is to the first power, but my leading coefficient is a 3. And the only way synthetic division will work is if that leading coefficient was a 1. So we're going to have to do algebraic long division, but that's okay. We can do it. Here we go. Check to make sure I don't need any placeholders. 2, 1, 0. I don't need any placeholders. That is my dividend. It goes under the long division symbol with my divisor going out front. I'm going to run through that 4-step process for doing algebraic long division. The first step is divide. X squared divided by 3x. I like to do that over here on the side. Once again, x squared divided by x leaves you with an x. 1 divided by 3 is 1/3. So 1/3 x. So we get 1/3 x. Step 1 was divide. Step 2, now we multiply. 1/3 x times 3x. The 3's cancel, leaves you with an x squared. 1/3 x times negative 2 is minus 2/3 x. Step number 3 is to subtract. Don't forget parentheses so that you remember to distribute that minus sign. The first terms drop out. They should. If those first terms don't drop out, you made a mistake. Go back and figure out what went wrong. 5x minus a minus 2/3 x means that I'm going to do 5x plus 2/3 x. And when you do that, I wind up with, 17/3. Bring down the negative 1. And we repeat the process over again. 17/3 x divided by 3x. Again, this is a mixed fraction. I have a fraction in the numerator of an overall fraction, which just simply means, right, the easiest way to deal with this is just take the denominator in the top and bring it down to the bottom. X's cancel each other out, and so you wind up with 17/9, which will be my constant. And now we multiply. 17/9 times 3x, the 3 and the 9, right, reduce to a 3 in the bottom, so it would be 17/3 x. And then 17 ninths times a negative 2, I wind up with negative 34 ninths. Subtract, leading ones drop out. Negative 1 plus 34 ninths leaves you with 25 ninths, which is going to be my remainder. So let's go ahead and write our quotient. We're going to have to do a little bit of work here, though. So I'm going to have 1/3 x plus 17 ninths plus 25 ninths, all divided by 3x minus 2. Now, here's the problem I've got with this quotient. It's got to be in standard form, which means that these coefficients need to be integers. So once again, I find the LCM of the denominators. The LCM of 3 and 9, again, is a 9. Just like we saw earlier, it just happens, coincidence, because the example problems I chose happens again to be a 9. So 1/3 times 9 is going to leave me with a 3x. 17 ninths times 9, the 9's cancel, and leaves you with a 17. Once again, 25 ninths multiplied by 9, the 9's cancel, leaving you with just 25 over 3x minus 2. And that is going to be the quotient of doing the function f of x divided by g of x. All right, guys, what we're going to do in the next video is take a look at what's known as composite functions. That's essentially where we're going to take a function and put it inside of another function. I can't wait to take a look at those with you. So head on over to the next page of the notes, and I'll meet you guys there.